Welcome to Tech Bytes and News, your personal generative AI podcast. So, IP addresses, huh? A seemingly boring topic, right? But Jeff Houston's January 2025 ISP column reveals a surprisingly dramatic story about the Internet's evolution. It's all about IPv4's dwindling supply and the surprisingly slow adoption of IPv6. Wild, right?
Yeah, I always assumed we'd have smoothly transitioned to IPv6 by now. It seemed like a done deal back in the 90s. What gives?
Exactly. Houston points out that way back in 1992, the IETF predicted the massive growth of connected devices. They nailed it, and IPv6 was designed to handle it. The problem? The transition's been glacial.
So what's the holdup? Is it just inertia? Is everyone just too lazy to upgrade?
Not quite. It's more complicated than that. See, the Internet shifted from a peer-to-peer model to a client-server one. That's where NATs come in. Network address translators let tons of devices share a smaller pool of public IPv4 addresses. It's a brilliant hack, really. Clever, but ultimately unsustainable.
Ah, I see. A temporary fix that's buying us time. But it can't last forever, right?
Right. Houston argues that this growth, even with NATs, is pushing the IPv4 system to its breaking point. We could see a fragmented internet, split into isolated pockets around content servers. Or, finally, a mass migration to IPv6. It's a real cliffhanger.
So the column examines the IPv4 address allocation data from 2024 to try and understand what's happening. And what did it find?
Well, the total allocated IPv4 address pool actually contracted slightly in 2023 for the first time ever. Crazy! But then it slightly increased in 2024. The growth rate is tiny though, almost negligible.
Interesting. So are we running out of IPv4 addresses? Is this the end of the line?
It's complicated. The IANA, which manages IP addresses, ran out of unallocated addresses years ago. There are some reserve blocks and some held by RIRs, but those are dwindling fast. There's also that huge Class E space marked for future use. But unlocking it is a major technical challenge.
So what about the IPv4 address transfer market? I've heard about that.
Yeah. RIRs allow for IPv4 address transfers between entities. The idea was to incentivize reuse of unused addresses. It's like a secondary market for IP addresses, but the results are mixed.
Mixed how? Spill the beans.
Well, the number of transfers is increasing, but the volume of addresses transferred is falling in most regions, except for RIPE-NCC. It suggests the market isn't very efficient at freeing up unused addresses. Plus, the prices have been fluctuating wildly.
Wildly? Tell me more.
The price per address went up exponentially in 2021, then dropped again. A real roller coaster. This reflects the uncertainty surrounding IPv6 adoption and future network growth. The market seems to be reacting more to speculation than actual supply and demand.
So what about IPv6? Is it finally taking off?
The IPv6 picture is also mixed. The number of allocations is growing, but the volume of addresses allocated is not. It's partly because of the variable size of IPv6 prefixes, making comparisons tricky. Plus, a huge chunk of allocated IPv6 addresses aren't even being advertised in the routing tables.
That's surprising. So what's the overall outlook?
Lots of uncertainty. While IPv6 adoption is growing, it's not fast enough to offset the problems with IPv4. Many providers seem to be banking on NATs to keep the IPv4 system afloat for longer than it realistically can. The future will likely involve a combination of IPv4, IPv6, and more reliance on NATs, leading to a more fragmented and less open internet. It's not exactly a rosy picture.
So it's a waiting game. A potentially messy waiting game. Thanks for breaking it down.
You're welcome. And that's all the time we have for this episode of Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.